Alright team, I'll just grab your attention. You can finish off that homework, and if you've got any questions about that, you can ask it. We're going to talk about Bob, and the reason we're talking about this is sometimes you're going to do some questions, permutation questions, where some of the objects in your list are the same. Right, so when you had to rearrange maths, all of the letters are different, but in Bob they're not. So let's just rearrange Bob by pretending for a moment that these are different letters. Okay? So we could have that one, Bob, like this, and then we could also have the corresponding one where we've got B2 OB1. Okay? What are the other options that we've got? Yeah. OB1 B2. And therefore the other corresponding one would be OB2B1. Anything else? We know there's 3 letters, so there should be 3 factorial, right? So there should be 6. What's the next one? Yep. Yep. Yep.
B1, B2, O.
And then finally? Okay, but since we have, if we just took these ones out that I've done to show you that, imagine if they're different letters, you can see that this is the same as this is the same as this, and this is the same as this. So we don't have 3 factorial options, we've only got 3 options, or 3 factorial divided by 2 factorial. Okay? Now we can apply this to something slightly more complex. So instead of Bob, let's talk about, whoop, I can't even spell, Daddy. Alright. We're not going to do all of the options for this because we'd be all day. But why don't we number these? Okay, give me another way that we could have exactly the same rearrangement, but we're just changing these subscripts. So, yep.
D2, A, D1, D3, D, and Y.
Another one? Yep.
D3, A, D1, D2, Y.
Alright. I want you guys to write a list of all of the different options you can find for what we've just done. And you should know how many they're going to be, right?
Yeah.
If you think about it, right, there should be, why?
You're switching 3 letters.
Switching 3 letters, right? So there should be 6, right? 3 factorial. We've got to find 6 different ways of doing this, right? Let's quickly do that. Can you give me the corresponding one to this one? D1.
D1, A, D3, D2, Y.
Yeah, what was this one?
D2, A, D3, D1, Y.
And the final one, Ishan, what do you reckon here? This one?
3, 2, D2, D1.
Okay. Right. Now, we're not going to do all of the other arrangements of these letters, but we know in total, if all of the letters were different, the permutations would be 1, 2, 3, 4, 5, so 5 factorial, right? However, we know that just for this one rearrangement, instead of there being 6, that's reduced down to 1, isn't it? So there are 3 repeated letters, and we're dividing by 3 factorial, because those letters can be rearranged in 3 ways. So the total number of ways we could rearrange Daddy in a way that looks different would be 5 factorial divided by 3 factorial, which is 20. 5 times 4, right? Okay, so this is the general principle of what we're doing in exercise 6.4. So let's try a couple together and then I can leave you to try a few on your own. Let's try something like Mississippi. So I'm going to just look at my thing here because I can't spell. So Miss I. Okay, now this looks a little bit more complex because what's more complex about this one? You're not just repeating one letter, right? Okay, so first of all, if they were all different letters, 11 factorial. What is 11 factorial? Just out of interest. What is it?
399.
Yeah.
16800.
Is that it? Okay, let's see how much having repeated letters reduces things here. So what have we got repeated? I's. Okay, so we've got 1, 2, 3, 4. So 11 factorial. But we're going to have to divide it by 4 factorial because those can be rearranged in 4 factorial ways, and it doesn't matter for them how they're rearranged because they're exactly the same. But what else have we got in addition? Yes. S. 4 again. So, anything else? The P's? 2. Anything else? Is that it? I think it's it. So, we're going to divide 11 factorial by, bracket 4 factorial times 4 factorial times 2 factorial, which gives us 4,000. Well, that's a substantial reduction, isn't it? Because of all of the double ups. It's still quite a lot, really, isn't it? Okay, so that's the general kind of principle of what we're doing in 6.4.